Welcome to ATDI. This is another webinar. This will be more like a tutorial, and we're going to talk about managing interference between 5G towers on new 5G sites and the aeronautical radar for the air traffic controller. Now that webinar is going to be detailed, and it's going to take roughly 40 to 50 minutes, maybe an hour. So first, let me introduce myself. My name is Yahya Khalid. I'm a senior spectrum engineer. I've been with the ATDI for roughly 10 years at the time of the recording. And you can see my contact details on the screen. So if you have any question, feel free to contact me. I'm based in Sydney, by the way. So the topics we're going to discuss today, first I need to give you a general overview of what I'm trying to do or how the process works. I'm going to also walk you through the project setup process, all the way from map download to 5G site importation, radar network modeling, and I'm going to shed light on the sanity checks that you need to go through, and move on to interference analysis methodology and running simulation and mitigation measures. So mitigation is about how to make sure the 5G can coexist, the 5G site can coexist around the airport. Not all 5G sites need to do coordination with the airport. So this is the model we're trying to construct, and we're going to do this together today. So the airport is in the middle of the screen here, and then you've got the radar, and we've got the 5G sites. And that first red circle is the 1.5 kilometers, and the second red circle is the 7 kilometers. So the coordination is needed up to 7 kilometers, and we're going to take the UK approach to spectrum to coordination, technical framework for the coordination process between 5G and ATC radars, as an example. So sites beyond 7 kilometers, they don't need to coordinate. Sites within 7 kilometers, they need to coordinate. This is a closer view. You see where the radar is. The radar is here, and then you've got 5G sites. And these 5G sites are randomly generated. They're not actual 5G sites. It's just for demonstration purposes. This is the model. So you're looking at the digital terrain model at 1 meter resolution. You're looking at the clutter model, and the red are the buildings. So that's the individual buildings modeled or captured in that process. Now you see here I have 1.5K and I have 7K. So 1.5K we're using specific propagation model in the simulation, and for the greater area up to 7 kilometers we're using a different propagation model, which is ITU 450. This is a 3D model, so we're going to do 3D. We're going to use 3D simulation in order to predict the signal. The signal from the 5G sites into the air traffic controller radar. So the building height is important if you want to feed this information into ITU 450. So the propagation model engine is going to make use of the 5G parameters and the radar parameters in order to, and also the digital terrain model and the building layer. You can see in red here we have the building layers, and you can see the software is capturing or calculating the reflection part of the signal and the diffracted part of the signal on the line of sight. So the tool is going to use different propagation methodologies in order to calculate the signal level at the radar. We're also going to model 5G antenna, so the smart adaptive antenna. So we're going to model the total transmission power, the antenna gain, which is the maximum antenna gain for the smart antenna, the transmission frequency and the bandwidth. We're going to model the smart antenna, the individual beams. This is beam 0, beam 1, beam 2, up to beam 7. So this antenna pattern has 8 beams. We're going to model the site as omni and also as individual sectors based on actual orientation of these sectors. So in the overview, now again here we're talking about the UK case. So in the UK, the radars are operating between 2.7 and 3.1 gigahertz, and the 5G sites could be operating beyond the 3410. Okay, so 3410 up to maybe beyond 3680. Okay, it depends. Now what we're really interested in, if the 5G transmission or assigned bandwidth is overlapping with the definition of in-band. Okay, so we have in-band requirements and we have out-of-band requirements. So as soon as the 5G bandwidth is overlapping with the in-band, then you need to do the in-band coordination. And regardless, you still need to do the out-of-band coordination because this is the noise part of the signal. So this is what we're trying to simulate. We have 5G. We have 5G somewhere in that band, okay, overlapping with that band. And then we have the radar operating on the adjacent band. So we need to check the impact of 5G into the radar. So you see here with the green example, if the bandwidth of the 5G is outside the in-band limit, then no need to do coordination for in-band. You still need to do coordination for out-of-band. If you are partially overlapping like the orange case, then you need to coordinate only for that part here, for the in-band. If your bandwidth assignment is going up to 350, for example here, then you need to coordinate for that part. If your frequency assignment is all the way capturing the in-band, then you need to coordinate for that entire part here. I'm not going to talk too much about beamforming antennas, but this is how beamforming is working. Okay, so you have individual beams running like this. So the base station is alternating the beams. So what we do, instead of modeling as a single beam, we superimpose all these individual beams and we create a composite beam like that one you see on the left hand side. So we combine these individual beams to produce something which is describing the worst case scenario. So let's go straight now to the software and then start the entire process. Creating a project and then importing the sites. So step number 1, you run HTZ Communications or HTZ Warfare, whatever the software you have. So when the software is running, when the software started, it will land on this landing page. Now that landing page, you could actually target a specific country. Okay, so you want to target the UK, for example. So you draw a rectangle. I want to download an airport or a map over a specific country. So you highlight the country and then you go to Map Download Manager. Now the Map Download Manager is going to list for you what maps are available from our online repository. Okay, so you see here out of the UK we have a number of airports available in 2-meter grid. Now the one I'm going to consider for this webinar is Bristol Airport. Let's see if it's here. So let's have a look again. This is Bristol. Here you go. So this is the one I want to download, the red part. So the software, the green is the area you highlighted. So any map we have in our repository, it would show up in that table. and once you click on it, it will show you where it is. Okay, what's the coverage. So you click the small icon here, download, and now you've got the second tab here. Now it's done. Now you can open the folder if you want. Show this in the Explorer. Here we go. This is the one. So I'm going to cut it, and I'm going to put it in a specific folder here called Live Project. So I'm going to paste it here, and then extract it. Extract files. Extract the files here. So it's coming with the building layer. It's coming with the RBL, which is the building layer, the terrain, and the clutter. It's not coming with an image. So for the image, you need to use what we supply. We supply usually a BIM key. Okay, so a BIM key is something we supply to our customers. It's giving you access to online maps. So we have a building now, we have a terrain, we have a clutter, and we have an image.